All right, now we're going to take a look at the law of cosines, another tool that we have, another theorem we have that'll help us solve other types of oblique triangles. Remember, an oblique triangle is a triangle without a right angle. So the law of cosines comes as really, I guess, a set of three equations here. And again, we've got a triangle where sides A, B, and C are opposite angles A, B, and C, respectively. For each angle that we might pick, we get an equation. So, like if let's say I pick angle A, this equation is a squared equals b squared plus c squared minus 2bc cosine of a. Notice that the side that is by itself on the left side of the equation corresponds to the angle that's used in that equation. And then that's basically the relationship. You'll notice it looks awfully similar. It's very close to being like the Pythagorean theorem. And in fact, you could think of the Pythagorean theorem as a special case of the law of cosines where the angle is 90 degrees. In this section, we're going to solve the other two cases. So case 3 is where I have two sides and the included angle, the angle between the two sides, like I know this, and I know this, right? And then the other case, the last case, is if I know all three sides but I'm not given any angles. And when in case 3, if I have two sides and the included angle, we use the law of cosines to find the angle opposite the known angle first. And if I know all three sides, I just pick an angle I want to solve for, and I use the law of cosines to solve for the angle. But I cannot stress this enough. It's a really good idea to find the biggest angle first, and we know that the biggest angle is opposite the longest side. So here's a case 3 example. I know two sides and the included angle. So here I know sides A and C, and I know angle B. And keep in mind, a lot of the time you go through and you do some exercises, most of the time the information they're going to give you is just in the form of this list, and then you have to be able to draw your own. So just remember that, side B is always opposite angle B, and side A is always opposite angle A, and so on. So in this situation where I have two sides and the included angle, we're going to use the law of cosines first to find side little b. So that's where we're going to start. And I'm going to use the version of the law of cosines that begins b squared equals, because that's the one that uses the known angle. So the law of cosines goes b squared is equal to a squared plus c squared. There's the first part that kind of feels like Pythagoras. And then minus 2 times a times c times cosine of angle b. Okay. I know everything. I have all the information to plug in everything on the right side of the equation. So we're just going to plug that in and take the square root on both sides. So b squared is equal to, 0.1672 squared plus 0.5143 squared minus 2 times 0.1672 times 0.5143 times cosine of 128.3 degrees. To find b, we just take the square root on both sides. Now, there's a lot of room for error in the calculator, like entering this in the calculator. I'm a fan of entering it in the calculator all in one go, and I'm going to do that here. If you want to approximate first, you can do that, and I'll show you that as well. Just you want to be careful because there's a lot of room for error. So let's see, plugging this into the calculator, I've got the square root of 0.1672 squared plus 0.5143 squared minus 2 times 0.1672 times 0.5143 times cosine 128.3 degrees. And I get 0.6317. Now if you wanted to approximate first just this expression, again, I kind of recommend just putting it in the calculator all in one go. It's important to keep in mind the order of operations. For example, sometimes people will find this and then they'll multiply the whole thing by cosine of 128.3. And that's not what this is. Okay? We have to understand that we are subtracting, we're adding and subtracting. I've got three terms here. I've got this, I've got this, and then all of this. This is all one term at the end. So if you wanted to approximate, I would just plug it in all in one go. Like so. And we find that b squared is 0.39905. And then you could take the square root from there. So we know side b is 0.6317. Now we need to find an angle. Now, what you choose, we had to start by using the law of cosines. But we're now in a position where I know an angle and a side opposite that angle. So we can use the law of sines to find either angles A or C. Keep in mind that when you use law of sines, it will never give you an obtuse angle, right? So you always want to make sure, if we're using law of sines, solve for an angle that we know is acute. Now, in this case, either A or C will do, right? Because angle B is obtuse, and a triangle cannot have more than one obtuse angle. So I know, I'm guaranteed that angles A and C are both acute. But if I wasn't entirely sure, I would just pick the angle I know is smallest. In this case, that's angle A, because it is opposite the smallest, the shortest side. So I'm going to use law of sines to find angle A. Now, you could also use law of cosines to solve for angle A, and we'll see an example where we use law of cosines to find an angle, but it's kind of simpler. The law of sines is a simpler equation just to use. So we know that A over sine of A is equal to B over sine B. I'm using B and sine B here because that's the matched pair that I have. And I'm going to rearrange this first just to solve for sine of A. I'm going to do the algebra before I plug in the values. So I'll take the cross product here. So I know that B times sine of A is equal to A times sine of B. And that means that if I divide both sides by B, that sine of A is equal to A times sine of B over B. And so angle A is arcsine of A times sine of B over B. Now I'm just going to plug in what I know, plug in the values. Let's see, side A is 0.1672 times sine of 128.3 degrees divided by side B, which is 0.6317. And I'm going to plug it into the calculator all like that. Alright, so I've got inverse sine of 0.1672 times sine of 128.3 degrees, closing the parentheses on the sine function, divide by 0.6317, close those parentheses, and I get 11.99 degrees, or if I round to the nearest tenth of a degree, that would be 12.0 degrees. So I know side B, I know angle A. The only thing we're missing now is angle C. So, and I can use the fact that they all add up to 180 to get that value. So 180 minus 12 degrees minus 128.3 degrees I get 39.7 degrees. Okay, so case 4. Here we're given all three sides and we don't know any angles. So we can pick an angle, and you really can pick any angle you want, but I'm going to try to pick an angle to make my work easier later on, because you know the law of sines is just sort of an easier, kind of simpler, smaller equation to deal with than law of cosines, so I like to use that when possible. And if I'm solving for an angle, the law of sines will never give you an obtuse angle. So I don't know whether or not this triangle has an obtuse angle, but I know that if it does have an obtuse angle, it's going to be this angle here, because it has to be opposite the longest side. So I'm going to start by using the law of cosines to find angle A. And the great thing about the law of cosines, and why it's so useful in this situation, is that, you know, we've mentioned several times now that the arcsine function will never give you an obtuse angle. It'll only give you an acute angle. But the inverse cosine, like the arc cosine function, that will give you an angle between 0 and 180. So if you're looking for an obtuse angle, the inverse cosine function will give it to you. And so if we use the law of cosines to solve for an angle that's the biggest, if it is obtuse, we'll know. And so we'll use the law of cosines to solve for angle A. And I'm going to just scroll back to the first page of this section. If I want to solve for angle A, I need the version of law of cosines that has angle A in it, and that's this top one. It's the one that begins A squared equals. That's the one that has cosine of angle A. So I'm going to start just by writing that out. A squared is equal to B squared plus C squared minus 2BC times cosine of A. Now, I could plug in all the sides first and, you know, have all these numbers in there, but I'm going to do algebra first. And what I'm going to do is solve for cosine A first. I'm going to use algebra to isolate that, and then once I know what cosine A is, I can apply the arc cosine function. So if I'm going to solve for cosine of A, I'm going to isolate this last term, the 2BC cosine A. So I'm going to subtract B squared and C squared from both sides. So then I have A squared minus B squared minus C squared is equal to negative 2BC times cosine of A. Now I don't like the negative here so much. I'm going to zap both sides by -1 just for convenience. If you didn't do it, you know, you can carry the negative through and take care of it a different way. But I'm just going to zap both sides with a -1. And when we do that, we get negative A squared plus B squared plus C squared on the left. On the other side, 2BC times cosine of A. And now I'm going to isolate the cosine of A, so I'm going to divide both sides by 2bc. So that tells us that cosine of A equals, and this fraction over here, I'm going to rewrite the numerator. I'm going to call that b squared plus c squared minus a squared, just because I like to lead with a positive, but you could still write it as negative a squared plus b squared plus c squared if you like. Okay, so that's what cosine of A is equal to, and that means that A, angle A, is arc cosine of b squared plus c squared minus a squared over 2bc. So now I'm going to plug in the values that they've given us into this. So that's arc cosine of, let's see, b is 22.62 squared plus c squared, 42.27 squared, minus a squared, 51.43 squared, all divided by 2 times 22.62, that's b, times c, 42.27. Okay, now we really have to be careful with the calculator. I'm going to throw this in the calculator all in one go, but then I'm going to show you, if you want, you can do some intermediate calculations if you prefer to do it that way. And the thing we have to realize is that in order to put this in the calculator, I have to understand that to put in this fraction, there are grouping symbols. I need to put a set of parentheses around the numerator to make sure that that's all on top. And I also need a set of parentheses all around the denominator to make sure that I divide by that whole product. So let's do it. Arc cosine, opening, so there's already a set of parentheses open for the arc cosine function. I'm opening parentheses, that's the numerator, 22.62 squared plus 42.27 squared minus 51.43 squared. Closing those parentheses, so now that's the numerator. Dividing by, opening a set of parentheses and putting my denominator in there, 2 times 22.62 times 42.27. Closing the parentheses in the denominator, closing the parentheses on the arc cosine function. I hit enter, I get 100.4 degrees. So, as it turns out, angle A is obtuse. We found it. Now I know that the other angles that remain have to be acute. Now before we find the other two, I'm just going to say, as I mentioned before, you can, figure out, do some intermediate calculations. So you could find this first. That's 22.62 squared plus 42.27 squared minus 51.43 squared. So that's negative 346.6276. And I would not round that much. In fact, I'm going to use all the digits there. Negative 346.6276. And then 2 times 2262 times 4227. 1912.2948. And And then I can do this division. Negative 0.181263. I would go out at least that far. Try not to round too coarsely. That can lead to inaccurate results. So negative 0.181263. And then I can take arc cosine of that. And I get 100.4 degrees. So you can do like intermediate calculations, right, to figure out what goes inside. Calculator errors, I'm spending a lot of time talking about potential calculator errors, and that's just because I see them a bunch. If you find, as you're going through this, that the arc cosine, like as you're plugging this in, it gives you an error, it's almost guaranteed it's because there's an error in how you entered it in the calculator. Maybe you didn't have parentheses where you should have parentheses, or maybe you punched in and used the wrong side length. You know, arc cosine will only accept values that are between -1 and 1, right? Because cosine values are limited by those that range. All right. So we've got this angle. Let's continue solving this triangle. There's two more angles we want to solve. We know that this is 100.4. I've got two more angles. I know all three sides. So now that I've used law of cosines to get an angle, I can use law of sines to get another angle. So let's say we'll find angle C. We'll use law of cosines to get angle C. So then C over sine of C is equal to, now I have to use A and sine A here because that's the only angle I know. We could plug in the values. You could do algebra now, which I usually do. I'm just going to go ahead, I guess, for variety, maybe I'll plug in the values that I know now ahead of time. So 42.27 over sine of C is equal to 51.43 over sine of 100.4 degrees. Taking the cross product says that 51.43 times sine of C is equal to 42.27 times sine of 100.4 degrees. And now we'll divide both sides by by 51.43. So that's what sine of C is equal to. That means that C is arcsine of this fraction. And let's see what we get. Inverse sine, 42.27 times sine of 100.4, closing the parentheses on sine, divide by 51.43. We get 53.9 degrees. So I know angles A and C. Now the only thing left to do is to find angle B, and that one's going to be easy because I'll just subtract from 180. And we get 25.7 degrees for angle B. And now you can go back and check these, right? We knew all of the sides. We were solving for the angles. So just going and doing a quick check. C was 53.9. degrees. Angle B here is 25.7 degrees. And we could do a quick check to see that yes, the longest side is opposite the biggest angle, the shortest side is opposite the smallest angle, and so this our solution, our answers kind of make sense. Oh, let's do one more. We're going to solve this triangle. They tell us angle C, and they give us sides A and B. So we know two sides in the included angle. That's case 3. And in this scenario, note that there's no, like a lot of the time we're going to be working through problems, so maybe we don't know if it's a law of cosines or a law of sines problem. And one of the first things I do is I scan to see if it is a law of sines problem. Just by seeing, do I have a matched pair? Do I know a side and the angle opposite that side? And I don't in this case, right? I only know one angle, and I don't know the side opposite that angle. So our only option is to start with the law of cosines, and in this case, we'll use the law of cosines to solve for side C. So I want to use the equation that begins C squared equals A squared plus B squared minus 2AB times cosine of C. I know everything, all the values that go on the right side of the equation. So I'll plug those in, and then we'll take a square root. 29.7 squared plus 44.2 squared minus 2 times 29.7 times 44.2 times cosine of 35 degrees. If you like, we can figure out what this is equal to first and then take the square root. So 29.7 squared plus 44.2 squared minus 2 times 29.7 times 44.2 times cosine of 35 degrees. We get 685.0627. And we can simply take the square root of that answer. So if on the calculator, if you want to use the previous result, just do second A and S. It's the little negative sign, and I'll just say use the answer from the last line. I'm going to take that square root. I get 26.2. And in this case, there were no units given attached to these sides, so there'll be no units for this side either. So there's side C. Now our next goal is to find let's see, angle A and angle B. Okay, so we have we've got a choice here. I can find either of them, and we'll note that we do now have a side and the angle opposite that side, which means we could choose to use the law of sines, right? Because I've got C over sine C. If we're going to use law of sines, though, I have to make sure, the angle that they gave us is acute. That means that it seems plausible that this triangle could have an obtuse angle. So if if it has an obtuse angle, I'm not going to find it with the arcsine function. So if I want to use law of sines, I have to pick angle A first. Okay, so let's do that. So C over sine C is equal to A over sine A. And we can do the algebra here. Cross product C times sine of A is equal to A times sine of C, and that means that sine of A is equal to A times sine of C divided by little c. And so A is arcsine of that. So I'm just going to go ahead and put those values in. Side A is 29.7 times sine of 35 degrees divided by side C, 26.2. $29.7 times sine of 35 degrees, close the parentheses on the sine function, divide by 26.2, and I get 40.6 degrees. There's angle A, and that means then that angle B is 180 minus 40.6 minus 35 degrees. And that's 104.4. So I said, after we found side C, we had a couple of angles to solve for, and I said, if we want to use the law of sines, we really need to pick angle A. You'll note that angle B was obtuse, and if we had chosen the law of sines to solve for angle B, we would have gotten an incorrect result. However, if you're worried about making that determination, about being able to recognize, maybe you'll be working quickly and you'll forget, like, oh yeah, I should have picked this other angle. Keep in mind that the arc cosine function will give you any angle from 0 to 180. So you can always choose to use the law of cosines. And if you use the law of cosines to find an angle, you know that it will give you the angle you're looking for. So, for example, we've finished this example here, right? This example is done, but we could, let's say we went a different route after we found side C, and we decided to find angle B using law of cosines. That will work. If you try to find angle B using law of sines, you're going to get the wrong angle. But if you try to find it using law of cosines, the law of cosines will never lead you astray. Will never give you an incorrect result there, as long as you kind of enter the things incorrectly into your calculator. We know that that's a risk. But if I wanted to find angle B using law of cosines, I use the equation that involves angle B, and that's the one that begins b squared equals a squared plus c squared minus 2ac times cosine b. And so let's say I'm going to just rearrange this to solve for cosine b. I'm going to go ahead and say I'm going to throw this on that side and this on that side, right? So I'm going to add 2ac cosine b to both sides. I'm going to subtract b squared from both sides. And that gives us the equation 2ac times cosine of b is equal to a squared plus c squared minus b squared. And then we divide by 2ac. Alright, so that means that angle B is arc cosine of that fraction. So B is arc cosine of, and I'm going to go ahead and put in the values now. So side A is 29.7, so we have 29.7 squared, plus side C is 26.2 squared minus 44.2 squared. over 2 times 29.7 times 26.2. Remember, when we plug this in the calculator, if we're going to do it all in one go, I need a set of parentheses just around the top. I need a set of parentheses just around the bottom. Okay, there's my parentheses for the arc cosine, open paren for the numerator. 29.7 squared plus 26.2 squared minus 44.2 squared. Close the parentheses for the numerator, divide by, open paren for the denominator, 2 times 29.7 times 26.2. Close denominator, close the arc cosine, and we get 104.3 degrees. So we were pretty close. I think it has to do with just the rounding that we had to go through, but these are consistent results. So if you're, keep in mind, I guess one of the most important things to remember when you're working with oblique triangles is that the arc sine function will never give an obtuse angle.